The collapse of that Bay Bridge I-bar last autumn shook up not just the bridge, but a lot of drivers who lost faith in the integrity of the bridge. The Bay Bridge, like so many others across the nation, is decades old, but now there may be a new high-tech way to detect when a bridge part or a bridge itself is about to fail. KTVU's David Stevenson explains in tonight's special report.
It's very difficult to put an exact number on how many of our bridges are fatigue sensitive.
University of Michigan engineer Jerome Lynch heads up a national project to make bridges smart, using high-tech sensors to alert engineers when sections are fatigued and close to failure in high winds or from overloading, which triggered the 2007 collapse of this Minneapolis bridge, killing 13 people.
We might underestimate the amount of fatigue structural elements might see within a bridge structure.
The project is funded in part by a $9 million federal grant. It includes applications such as this so-called sensing skin.
For example, we can actually place this on the interior of a structure, say in a bridge deck, and measure the amount of corrosion that's occurring on the interior of the bridge deck just by wirelessly reading this from afar.
The immediate goal is to deploy cheap wireless sensors on every major U.S. bridge. Sensors that can make complex measurements without hundreds of yards of cable. Some are even powered by vibration.
It's a fairly low-cost prototype costing about $100 per sensing node. You can see it has an antenna for its wireless communication capabilities.
Those collaborating on the new technology say it'll be at least 5 years before the first generation of sensors are ready for the commercial market. In the meantime, some of the technology is being tested out on this Bay Area bridge. Last November, University of Michigan engineers partnered with Caltrans and a South Bay company to test about a dozen wireless sensors on the Carquinez Bridge. It quickly became a case of too much information because the sensors generated gigabytes and gigabytes of data.
The problem with doing sensors is it's not only getting the data out, but making sense out of it.
Engineers at Sunnyvale's SC Solutions are using mathematical models to organize that data and decide where to place sensors.
The bridge deck is a good example of where it gets complicated because it's a continuous, it's like a kilometer long. So there's almost an infinite number of places where you could put a sensor.
The idea is to make it simple for bridge operators to understand precisely where and what the problem is.
If the maintenance department has a screen that says green light, or yellow light, or red light, that's all they really want to know. And if there's a yellow light, go look over there.
Caltrans says there are already more than 100 motion sensors on the Bay Bridge and dozens more on the Carquinez that measure movement created by an earthquake. Officials say the next generation of sensors, those fatigue measuring sensors, may offer a better understanding of bridge stress before and during an incident.
When you have good hard data on what any bridge is going through during an earthquake or even during high winds, that knowledge is golden.
In Oakland, David Stevenson, KTVU Channel 2 News.